right, let's take a look at the quiz yourself questions for section 2.2. Here we're looking at equal sets. Sets are equal when they contain the same members. Determine whether each statement is true or false. The set Socrates, Shakespeare, Beethoven is equal to the set Shakespeare, Beethoven, Socrates. That's true, because order doesn't matter. Every element in one set is in the other. They have the same members, right? In B of Quiz Yourself 6, tigers, gray whales, and giant pandas certainly are in the group Y, such that Y is an endangered species, but there's things on the endangered species list, like every sea turtle, that's not on the list: tigers, gray whales, giant pandas, right? So those two sets are not equal. That's a false statement. In order to say not equal, we would take an equal sign and cross it out. For equivalent sets, we're asking if the sets have the same number of elements. So Socrates, Shakespeare, Beethoven has 3 elements. Tiger, gray whale, and giant panda also has 3 elements. They're not equal sets because Socrates is not in the list of tigers, gray whales, and giant pandas. So they're not equal sets. They don't have the same exact numbers, but they are equivalent sets. They have exactly 3 members. Each set has the same number of elements. Another key point is to look at subsets. The 2 sets from the Quiz Yourself question part B from above is an example of a subset, where one set is a subset of another if all of its elements are found in the other set. Like we said, tigers are in the set of all Ys, such that Y is an endangered species. Gray whales is in the set of Ys, such that Y is an endangered species. And giant pandas are also in the set Y, such that Y is an endangered species, right? So we have an example of tigers, gray whales, and giant pandas being a subset, which is this symbol here, looking like a C with a line under it. Venn diagrams are one way that we'll illustrate sets. This Venn diagram is shows the relationship between sets, and it is of what we just described, the subset. It's really truly the picture of a proper subset, where proper subset means strictly less than, right? So although they called it a subset, I would call this a proper subset. Oops, nothing. Sorry about that. Okay. Quiz Yourself 7. Decide whether each statement is true or false. So again, here we see the subset symbol, right? The subset symbol. And in the first example that we have, letter A, we're being asked if 2, 4, 6, 8 is a subset of 1, 2, 3, 4. The ... in each one means the pattern continues on, right? So for example, if we were to list out the elements in the 1, 2, 3, 4, that ... means continue on in this pattern. And you can see that we are in fact seeing all even counting numbers. So yes, 2, 4, 6, 8, and all even counting numbers, dot, 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 going on forever, is in fact a subset of just the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, on and on and on forever. Now in the table for the example in the book, I just included the table here below. We're being asked if B is a subset of S. So B, for example, if we were to write it in set builder notation, right? B would be all athletes called B, little b, such that B won a bronze medal. And S are all athletes, S, such that S did the event called slalom. So what B as a subset of S means is every athlete on the list of bronze winners is from the list of the athletes who did the event slalom, right? So if we look at our list here, we have, speed it up a little more, we have a bronze medalist in these 3 places. So B, the set B, for example, is Heinrich, Hannah, and Martin, because they had bronze medals, right? Now let's look at the group S, right? Who is S? S are the athletes who competed in the event called slalom. Slalom. That is Matthias, Tina, and Heinrich. So when they're asking us if B, or they're trying to claim, right, their claim was that B is a subset of S, we can say that's false. B is not a subset of S, right? In fact, the only person on the list that comes from S is Heinrich. But Hannah's not on the list and Martin's not on the list of S's, right? So that's false. That one's false. For Quiz Yourself 8, we're looking at finding all of the subsets of the set 1, 2, 3. So a 3-element set, and we're going to look at finding all of the subsets. And I already listed the subsets out here below, but the subsets are always the empty set itself, any 1-element sets that you can form, any 2-element sets that you can form. Try to be systematic. Now I've exhausted the 1 pairing it with things, but now if I try to pair the 2 with the 1, I've already paired it here, right? If I try to pair the 2 with the 2, then we said repetition doesn't matter, and so we don't even count that 2. So it boils down to that set there. So we don't use the 2, 2 either, right? We can use the 2, 3 as a pair. Oops, not 33. And then again, if we grab the 3, we try to pair it with the 1. We've already done that. If we grab the 3, try to pair it with the 2, we've already done that. And if we grab the 3 and try to pair it with the 3, we've already done that. So we're exhausted on pairs. And then how many 3 element subsets can we make? The set itself. So we have 1, 3, 3, 1, or a total of 8 subsets. So find all of the subsets. Here's all of the subsets, right? Which I listed out for us here. And I listed out for us so that we could look at some other base cases, right? Here we have a set of size 3 as our original set. If we then look at a set of size 2, how many subsets can we form out of a set of size 2? Well, even looking at our list before, we can cross out anything with a 3, right? And then we have our list here. We've got the empty set, the 1, the 2, and the 1, 2, right? So we had a total of 4 subsets when we have 2 elements. We've had also a total of 8 subsets when we had 3 elements. If we started with an element that was with a set that was only 1 element, right? Only 1 element, then all the subsets are the empty set, right? The container itself, and the set of size 1 that has the element 1. So two subsets when your original set had 1 element, and 1 subset when your original set has 0 elements. So if you're just starting with a container, then the only subset you can make out of that is the container, right? And so if we take a look at what we have here, we can shrink it a little so you can see the whole thing. Then what we have is that when when n equaled 3, right, the number of subsets equaled 8. When n equaled 2, so n being the cardinal number, the number of subsets is 4, right? Half as many. When n equaled 1, the number of subsets was 2. So although we viewed it in a way when we have n equals 0, number of subsets is 0, although we viewed it in a way we saw it shrink, in reality, we would start with the case 0, and then we would move to the case n equals 1, and then we would move to the case n equals 2, and then to the case n equals 4. And in that process, what you're seeing is you're seeing the number double, right? We started here with a 1, and then we multiplied by 2, we doubled. We have a 2, we go up, we add 1 element, and we double, right? We go up 1 more element, and you double the amount of subsets that you have. And so what we're getting as a result of this, right, is we're getting this formula here, that the number of subsets of a set is 2 to the k. So if a set has k elements, which I just called n because we already learned the notation n of a for cardinal number, that that's all this k elements is, cardinal number. So n of a, that is k, right? K sounds like cardinal number, so it should remind you of cardinal number. But we already have a notation for that. So you're welcome to leave it 2 to the n if you want, or you can use 2 to the k, whichever notation you prefer. But let's test it out. When we had a set with no elements, 2 to the k is 2 to the 0. Anything to the power 0 is 1. We had one subset, right? That checks. That checks with what we got here. Now, when k is 1, so going to this next one up, we have 2 to the k, which is 2 to the 1, or 2 subset, which checks, right? So we're checking our formula, we're verifying it. When we had k equals 2, so when we had that set with 2 subset, 2, go up a little. When we have this set, the 1, 2, we end up with 4, right? So let's test that out. When we have k equals 2, we have 2 to the k, or 2 squared, which is 4 subsets. So again, check, check, right? It's all, it appears to be working just fine. And then the one we started with was k equals 3, right? So 2 to the k is 2 to the 3, and that's 8 subsets. So we can, in fact, verify it, right? And also, again, we're doubling. So if through our verification, we just doubled every time, then when k equals 5, we should have 32 subsets, right? By the doubling. I have a list on my, there we go. Oh, goodness. Okay, so let's look at Quiz Yourself 9. If the set has 5 elements, that's what we were just looking at. How many subsets will it have? We said 32, and we based that on just doubling, right? But if we use the formula, 2 to the k equals 2 raised to the power 5, which equals 32 subsets. And in Quiz Yourself 9, Part B reads, how many subsets can be formed using letters of the alphabet? There's 26 letters in the English alphabet. So we have 2 to the power 26, which is 67,108,864